All right. I hope you enjoyed the coffee break. It's almost 11, so let's get back to it. So under normal circumstances, you should have gotten an email by now. And then if you click on the link, you should see something like this here. Fortunately, because we had so many user power, we just executed a successful DOS attack and the server went down. So we eventually need to wait till Ming wakes up later and reboots the thing. Also, fortunately, we do have a backup server for situations like this and for beta testing. So we could actually open the job here on our beta server. And I'm just going to quickly walk you through here. I'm not going to tell you how to use it because we actually do not want you to use it. But there is a backup option. So just so you know. Yeah, so typically what you will get, yes, this long link, this long URL in your email, and then this is like the first few, so this is the main page of your job results. And there is a lot of information in here. So don't get overwhelmed. I'm just going to show you briefly what I typically look at first and what I think is the most important views. And then I'm also going to show you how to download the data. So of course, we want to know what did we identify. So that's why I typically go first here on view all library hits. And yeah, when you click on this, then like, yeah, a new window should pop up such as this, where you get like a long list here with like different molecules that were annotated. And I typically first look at this number here on the top. I hope you can see it well. Let me zoom in a little bit more. Which says that hits 1 to 30 out of 245 are shown, right? And that is, now you can imagine, okay, how many features did we have yesterday? You can see already, okay, what percentage of annotation you have. And then it's typically sorted here by like the cosine value. So again, this is the matching score between like the library spectra and your experimental spectra. And then here, one that would be a perfect match. And then as Scott showed you earlier, you can click here on like this mirror match and actually inspect the quality of your match. And I would strongly encourage you to do that, especially before you write the name of this compound into your manuscript. So I think here, yeah, like manual verification or inspection is important. Obviously, if you want to do this now with like, I don't know, 500 molecules, it gets a little bit challenging. But if you identify something as a putative biomarker, then you want to show something like this. You want to inspect it and then also put this in your figure, right? And that, I think, adds confidence. So yeah, like this mirror match view here, beautiful. You know, we have many matching peaks, like the intensities perfectly matched, so this is great. And then also, in addition to the cosine value, we see here that we have an MZ error of 4 ppm. And that was like the mass accuracy of like the Orbitrap or QTOF. That data was acquired on, that is typically within a good range. Few exactly. Could be a little bit better. For the QTOF, I would have said it's excellent. All right, and then yeah, we can scroll through and look at like other you know, molecules that might be of interest. And yeah, just like as a first view, that's typically what I look at. If you scroll all the way to the right, for all the library IDs that contain SMILES code, there will be also like the molecule drawn. And it's like the natural product chemists here can share the fascination by quickly of quickly like scrolling through structures and see, oh, there's a new moiety, or this looks interesting, whatnot. For me as an NT, oh, they just indicate basically like the different atoms, right? So it makes it like easier to like see, oh, this is a nitrogen, or here's a sulfur. And yes, a lot of my research deals with like antibiotics, obviously. And here, when I see a molecule like this, I'm getting interested, not necessarily because this is a new natural product, but rather because this is an important antibiotic, sulfonamide. And then, you know, I could then further inspect what else is connected to here, right? And that brings me actually like to the second view. I typically, right after the library IDs, go to. Yep. Depends on the setting. So for the online participants, the question was, here we only see like the top one hit. I don't know which workflow exactly you can do it, but there is, I think, the library dereplication one, you can actually set like the top number of hits, which sometimes might be useful. In this view here, it only shows you the top one hit. But yeah, if you want to add, yes. I don't think in feature-based molecular network, but in the library dereplication workflow, you can adjust it. All right, so yeah, like annotations are like the first like dimension or like type of information we're interested in. And then of course I want to also like look beyond the ID'd compound, but actually look at like the rest of like the chemical space covered. And therefore I typically go to here, view all spectra with IDs. And this, when you click on it, you will then also get a list. And actually, not only see annotated molecules, but now all the network nodes of your network. And you can see here at the number, this is 1 to 30 out of 6,182. That's of course already much more. And also as a sanity check, this number should correspond precisely to like the row number of your feature table, what you generated yesterday in NZMine after exporting like the final feature table. So now, because I already mentioned like that sulfur drug, right? Sulfur metisol. I can now search for this in here by navigating to the library ID and then just type in sulfur, and then it should help me to like find this. And there's actually two compounds with like the sulfur string in it. But yeah, like here this first one is what I got excited about. And then if I now want to like investigate the network, I can like look here under spectral family, if there is actually a molecular network generated that contains like this node. Unfortunately, here is a view network button now. So that means that like this feature was like connected to other features in a network. And when I click on it, then like here, like this new tab should open with like this in-browser network visualization. So now I see like the molecular family of particular this molecule. So all the neighboring nodes that were connected. And then I can like interrogate and check what is like else in this network. So I zoom a little in, and then I can like here select like the labels, such as like parent mass, and I see, oh, okay, some of them actually have very similar masses. So perhaps that could be an artifact from like the isotope pattern, or maybe it was like a mass delta of 2, it could be like a like some different redox products. And then I also see here, oh, there's actually like a larger mass. And if I want to annotate this a little bit like more conveniently, so I don't have to do the math in my head, I can label the edge with like the delta MC. And then I will see here, okay, 27.995. So now for me, first, what I see is this 0.995. That means negative mass defect. That means probably there is an oxygen involved. But then, yeah, I can like click on like the two with like left and right mouse, and then visualize the spectra, and then kind of like continue like this manual inspection. And now 27.995. I think this could be carbon monoxide, right? So now we could think about, okay, where could we add a carbon monoxide in the structure? And we see the structure here on the right, and build up our hypothesis from there. So I hope you will find this useful for some of your particular molecular cases. But yeah, so now this shows the network in a node-centric view. So only the molecular family of actually like compounds connected to this one. What about like all the rest? So those you can't really like visualize in this particular viewer, but we can actually now download all this data. So everything that is now here accessible online, we can like download on our computer and then use advanced network visualization tools such as Cytoscape. And therefore, we can click here on download Cytoscape data. And then, I'm actually going to do this to show you. There will be often like, this is too large to be visualized in the browser, but don't worry because the download button here works anyway. And then I'm just gonna download all results. And if I do this, I typically get or I will get a zipped folder, which I can then extract with like, I don't know, WinRAR or any other like file extraction tool. And then I will here get like such a folder, Proteus save with like a long string. And now, because we killed the server, I actually downloaded it for you from our beta server and uploaded it on a shared Google Drive. So if you go to the Google Drive, then you should be able to see now a GNPS folder under the data folder. And then in there, there's exactly like this folder. So yeah, feel free to download it later for like the Cytoscape exercise. You will need this together with the files that Markus and Fleming gonna generate with you in a second. And yeah, I just wanna briefly show you what is actually in there, because again, the amount of information can be quite overwhelming. But if you understand like the file structure and how to like navigate with it, it's actually not that complicated anymore. So most of those files are TSV files, so you can simply open them in a text editor or Excel or open Office Sheets or whatever. And then if I want to now look at like the, you know, like library hits here under DB results, for example, I could hopefully open this on Scott's computer with Notepad. And then, you know, I would get like, again, like this long list of like the IDs, you know, the same way I had it in the web browser. The difference is I don't have like this interactive visualization of the mirror plots, which I think comes very handy in the online tools that I typically use. But obviously here it's much more easy now to filter and handle this data. Then in addition to this list, you know, there will be the feature table that we actually submitted under the quantification table. So this is the similar or like the same feature table as you exported yesterday from GNPS. Okay, here it's actually already recognized to be opened in Excel. And then, you know, like feel free to actually open this and look into the data, because I think understanding it is very important for like the downstream statistics. And yeah, basically what you get is here, like this big table. Okay, here it didn't recognize it, but I think if I go to data and convert text to column, I can use like the comma as like a delimiter, and then hopefully display this. There's already data. Yeah, display it in a nice like table format, right? And I think from a very basic perspective, this is now our molecule table. So if you dealt with like sequencing data and ASV tables before, this is kind of like an equivalent. And now like all the table juggling in Excel, R, Python, or whatever, you can do it the same way you may have done it with like other data types. So just for that. And then what is going to be most important for our Cytoscape workshop later, there is also like this GraphML file. Yeah, which is basically a file that contains all like the network information, which we can then just drag and drop into Cytoscape. And I think, maybe it's just like one little gimmick that might be very useful. So I love to look at this. GNPS is like linked to QIIME2, which is a statistic platform for microbiome data science. And you directly get like here this QIIME2 outputs. And this contains a default principal component analysis. And here you have already like all like the output files ready to be used, right? And now technically all I need to do is go to QIIME2 view and then drag and drop this QZV file in there. And then if the metadata was correctly formatted, I should be able to visualize this PCOA plot. So here, Emperor QZV, and then here we go. And we can already see that there are some strong differences between some of the sample types. Now, hopefully, nice, as the metadata was correctly formatted, I can now color code them based on this metadata. And I would assume that, oh yeah, here we see nicely that we have a strong difference between the plasma and the skin samples. So maybe this is exactly the situation which we should not do in our statistical analysis, compare like two different samples, right? But we also see, well, as a first sanity check, they cluster like tightly between the categories. So overall, it seems good. And then our planks also are kind of like far away and close to each other. So as a first sanity check, I would feel now already more confident about this data set and about the metadata and its format. All right, so this should be all available to you. So yeah, feel free to play around with later during the hands-on session. And I think from the GNPS side, that was pretty much all we wanted to show you for now. Again, you will need these files later for Cytoscape, so please download this folder. And now I would hand over to Markus and Fleming, unless there are some more questions. Very good question. So the question was whether we will only get library hits or also like similar compounds that were annotated. If we select analog search, then you will also get like the analog matches. And then there will be another very important, let me actually show you. There will be another important information that this is like the absolute delta mass, which then obviously will contain matches that is like higher. So here there's this mass difference. And then if you would get an analog match, then you would have then a larger mass difference here. So this is akin to like open modification search and so on. So we didn't generate it, but at the very beginning, when you submit a job under advanced library options, there is the question whether you want to perform analog search, and you can turn this on and off. By default, it's turned off because it's a little, more like risky to give this to new users, because then they will think it contains all these molecules, but they actually have larger mass offsets and something completely else. But yeah, for advanced users, I strongly encourage you to like play around with it. I really like using this. This boosts the annotation rate obviously tremendously, but then those are all then level 3 or level 4 annotations. All right. Unless there's any more questions, then thanks, and I'll hand over.